div 3, right? Let me just quickly see if everything's all right on both ends, and if it is, then I think we are good to go, right? Just give me a minute. Let me quickly check. Good afternoon. All right, I think everything's all right on both end. A lot of people have joined in. Welcome all of you. We'll just wait one more minute. Okay, we'll just wait one more minute and then we will start the class. All right. Let me quickly see if there are any issues on any end. Perfect. Great. I see many students are joining. Perfect. We're going to have a wonderful session today. I hope those of you who attended the 11 to 1 lecture as well, they had time to take a break as well. Perfect. I'll just apologize in the start only, because I'll not be able to see all the chat continuously. We have teaching assistants present who will be helping us throughout the class, right, and taking sure every doubts that we have. So they will take up each and every doubt that they have, right, on both the Unacademy and the YouTube platform, right. I'll not be able to take the doubts at every point, but I'll see from time to time if there's any doubt so far or not, right. Please make sure and feel free to ask any doubts that you have throughout the session. If there's any point you feel that you are left behind or some concept is not clear, please make sure to put it in the chat. Someone from the teaching assistant part will make sure that they take care of your doubts. Okay? So that part will be done. Other than that, we'll be covering 2 topics today. So we have a lot to cover, and we have a 2 hours timeline as well. So we'll try to cover everything that we have during this time domain. Okay? So we'll try to have a fun session today. We'll try to make sure that after 2 hours, we are able to learn a very important concepts. Okay? Just to set the right expectation, everything will be covered from entirely scratch. So I'm going to literally assume that you do not have any prerequisite knowledge, right? I'm going to assume that you do not have any prerequisite knowledge about the topic that we are supposed to discuss, and keeping that in mind only, I will be teaching you the class. Okay? So for those of you who do have a knowledge about sorting and searching, you will be able to revise your concepts as well. Okay? A very wonderful class that we're going to have today. Before starting, I think we do have sufficient audience on both the platforms. Before starting, let's quickly take an introduction. I'll just quickly take a minute again for those of you who are attending for the first time to introduce myself. Okay? So my name is Riya Bansal. I am currently working as a software engineer at Flipkart. Previously, I have worked at Amazon and Coding Blocks and American Express as well. Right, so we do have an Ask Me Anything session also just after this class will end, about from 5 to 6, where you can ask any doubts that you have regarding the placement strategies for full-time roles, for internship roles. Any doubts that you have, you will be able to clarify those doubts as well. Okay? So please make sure to attend that session as well. Other than that, I am very passionate about teaching. I do have a lot of teaching experience. I have mentored many students and helped them crack the world of competitive programming. So I'm hoping to help you learn today as well through this class that we have today, right? Okay. So I think everyone has a thumbs up kind of a button in the chat, which all of you must be able to access, right? So I will suggest to make use of that option as much as you can and give a thumbs up whenever you feel you have any concept that has been clear to you. ठीक है, तो अगर किसी भी point पे, if there's any point that you feel a concept is clear, please feel free to give a thumbs up so that I know that the majority of class is clear. So if there are, let's say, 500 students and let's say 200 students or is giving a thumbs up, or let's say 400 students are giving a thumbs up, so that means that is a good indication, है ना? That is a good indication that the concept is clear to you, right? So we'll follow that particular strategy. ठीक है, let me share my screen once and let me know if the screen is visible to all of you or not. ठीक है, because I'll be using a drawing pad to teach. I hope everyone can see the screen, right? Perfect. चलो, good to go. ठीक है, तो instead of actually going into any sorting algorithm and actually discussing anything else apart from that, let's just define a particular definition that we all everyday know, right? Now, what do you think? What is sorting? Now, I want all of you to answer in your own terms. What do you think sorting is? How would you define sorting? I just need different answers from your end only. Anything that you feel is a way that can help us say that this is called sorting. Okay, let me check on both ends. Correct. Okay. Very good. I see everyone's is already efficient enough to understand all the things. All of you are correct, right? All of you are correct. So when I say sorting does not mean ascending or descending, है ना? This is not the only way to describe sorting. When we say sorting basically means arranging things in an order, है ना? It could be anything. Now when I say order ना, तो when I say order at this point, this order could be anything. This order could be the ascending order, or it could be the descending order, ठीक है? Or it could also be based on the प्रॉपर्टीज ऑफ द सेट, ठीक है? तो यहाँ पे थिंग्स भी कुछ भी हो सकता है. इट कुड बी एलिमेंट्स, इट कुड बी I can say particular shapes or anything like that. And when I say order also, order के भी there can be many meanings to that, ठीक है? If I have to take some examples to help you understand this thing, so I can basically say that let's say I have an array, ठीक है? Now array is nothing but, let's say in my example, collection of numbers, है ना? So when I say collection of numbers and if I have to sort it, now here sorting could mean I have to arrange them in the ascending order, ठीक है? And it could also mean that I have to arrange it in descending order, ठीक है? There could be any meaning at this point. Another example would be that let's say I have been given some rectangles, है ना? आपको कुछ rectangles दे दिए हैं and you have to sort it. So this is how it looks like. So this is one rectangle, है ना? And let's say this is another rectangle. So these are all the rectangles that I have given to you. So when I say sorted, ठीक है? Now the question comes basically how to sort it, है ना? So one of the ways that I can think so far to sort it, basically I can, first way could be on the basis of length, है ना? If there are two sizes, if one length is less than the other, so I can basically do in a length kind of a basis sorting in terms of ascending order. The second type of sorting could be on the basis of breadth. Let's say I have to do this kind of a sorting based on the size of the breadth. and that also is again ascending, or it could be descending also. The third type at this particular point will be, let's say I am doing it on the basis of area, है ना, that means which one has the area greater, है ना. So I can also do it on the basis of area, ठीक है. Another basis could be perimeter, है ना. I can also sort all the elements on the basis of their perimeter as well. So here I am proving just another property, that sorting can be done based on the properties of the elements as well, ठीक है. Now what we basically want to do is, if let's say I am given some elements, let's say the elements that are given to me, let's say some random numbers, let's say I have got 20, I have got 40, I have 10, I have 15 and I have 25, ठीक है. And I have been given to sort the elements, ठीक है. Your task is to sort the elements, and you have to sort the elements, ठीक है, and you have to sort the elements in the ascending order. So ordering given to you is this. Now tell me, what approaches do you think comes to your mind? Think of the worst approach, ठीक है. Now at this point I want you to think of the worst approach, the approach which is going to take the most time, ठीक है. Think of the worst way to sort this array, ठीक है. We always talk about efficiency, right? We always talk about efficiency. Let's talk about an inefficient process as well. Then I will make a very strong observation about that. What do you think is the way that is going to take the most amount of time? Okay. Many of you are giving the same answer, I believe. Acha. Most of you are saying that bubble sort is the worst way to do this process. ठीक है, ठीक है. Most of you are giving the complexity also, that it is going to be order of n square. ठीक है. Now let me share my approach. ठीक है, let me share my approach. I think the worst way to solve this, or the worst way to sort this, is going to be taking the permutations of all the elements and picking the right permutation. ठीक है, ये अप्रोच है विच आई थिंक इज द वर्स्ट. एग्जाम्पल ले लें. लेट्स टेक एन एग्जाम्पल. लेट्स से द एलिमेंट्स आर 2, 3, 1, 4 and 5. Now I will find all the permutations for n elements. How many permutations do I have? N factorial. So I will first have all the n factorial permutations. Let's say 2, 3, 1, 4, 5, 2, 3, 1, 5, 4, then 2, 3, 5, 1, 4, then 2, 3, 5, 4, 1. Right, I will go in this manner. I will form n factorial permutation, and one of the permutation is, let's say, going to be in this manner also, and this permutation is my answer. So the first step will be find all permutations, and the second would be pick the correct permutation, है ना. And according to my approach, the overall complexity for this will be to find all the permutations, ठीक है, to find all the permutations and to pick the best permutation, ठीक है, the total time complexity is going to be n into n factorial. And don't you think this is way worse than the bubble sort? How many of you agree to that n into n factorial is way worse than n square approach? That is why, ठीक है, that is why when anyone says to have the worst approach, nobody is going to answer bubble sort now, ठीक है. Bubble sort is actually a very good way to sort all the elements. The worst way is to take the permutations and then sort the array, ठीक है. Many people don't know this. They think that bubble sort is that sorting algorithm which is the worst sorting algorithm, but actually that is not the case. There are even worse sorting algorithms as well, ठीक है. If you don't know what bubble sort is, that definitely fine. That is another just to give you a brief, that is another sorting algorithm that is not very optimized, ठीक है, and that works on the basis of swapping. We are not going to cover bubble sort in this class, but that is another sorting algorithm which is not considered optimized. But we have another, we have another approach to sort all the elements which has even, I would say, worse way to sort this, ठीक है. चलो, now what we want is, whenever we are performing sorting, ठीक है, whenever we are performing sorting ना, we basically want the algorithm to be very efficient, है ना. This is what the approach will be. Whenever, let's say, I am sorting, I always want my sorting algorithm to be very good, है ना. Otherwise, what is the concept of doing sorting? If you want a real life example, ऐसे सोचो, there is a company which has a very big database, ठीक है. It is maintaining information about a lot of people, ठीक है, and now it has to sort all the information on the basis of age of the people, ठीक है. And let's say it has 1 million entries, it has almost over 1 million entries, and if it has to sort all the entries on the basis of age of the people, अब सोचो, if you are using a bad sorting algorithm, exactly how much time will it take to sort all the elements, है ना. It is going to take a lot of time, है ना. तो what we always want is, we always want our sorting algorithm to be very efficient, ठीक है. It should take the least amount of time, ठीक है, and also it should take less space also. So that will be our motive here as well, ठीक है. So when I say our algorithms has to be very efficient, or we have to say good, so what exactly is a good algorithm? ठीक है, what exactly is a good algorithm? I can basically say at this point that an algorithm is going to be good or efficient if it has a good running time, ठीक है, and it uses less space, ठीक है. तो there are many sorting algorithms. अब ऐसा होता है, in order to sort a particular, in order to use apply sorting ना, there are multiple ways to do this, right? I have many sorting algorithms. I have got bubble sort, insertion sort, selection sort, merge sort, quick sort, radix sort, heap sort, bucket sort. I can name like endless sorting algorithm, and you can always just invent your own as well. But all of them are obviously efficient, ठीक है. All the algorithms that I named are very efficient. They have a very good running time, and they uses less space also. It just depends on your use case which sorting algorithm that you have to pick, ठीक है. So what we actually are going to learn today is, we are going to pick only one sorting algorithm because we have because we have time constraints, ठीक है. Having the time constraints, we are going to discuss one sorting algorithm today, that is going to be insertion sort, ठीक है. So let's quickly have a look how exactly we are going to learn another new sorting algorithm, ठीक है. So let's say I take an example and then try to learn this. Imagine you are playing a game of cards. ठीक है, ऐसा assume करो, ठीक है, ऐसा assume करो that you are playing a game of cards. ठीक है, and initially your left hand is here, ठीक है, and your right hand is here. Correct. And what you have to do is your right hand has some cards. Let's say it has 6, it has 9, it has 8 and it has 11. ठीक है, and what you have to do is your task is pick one character one by one from a right hand let's introduce for better styling some lines also. Okay, you have to pick one character one by one from right hand and you put it into left hand. Also always keep a sorted arrangement in left hand. When I say sorted, I mean ascending order. ठीक है, अब देखते हैं how exactly we are going to solve this particular problem. ठीक है, let's quickly have a look how we are going to do this. Okay, this was our left hand and this was our right hand. ठीक है, तो आप ना रियल लाइफ सिनेरियो से इसको विजुअलाइज करने की कोशिश करो. Try to visualize from a real life scenario of how you will solve this problem. So the element was 6, 9, 8, 11. Okay, so what I'll do is I'll take the first iteration, I will pick this card and I will place it simply here, है ना. Now each element, or I would say if there is only one element, it is always sorted, है ना. तो अगर single element है तो कुछ sort करने की ज़रूरत ही नहीं है. So I will have a 6 here, I have a 9, 8 and a 11, है ना. In the next iteration what I will do is I will pick a 9, ठीक है, I will pick a 9 and I will see there is already a card and I will compare 6 and 9. Now 6 is less than 9, I am simply going to place it after. So it will be 6 here, 9 here and 8 here and 11 here. ठीक है, now this case is going to be interesting, make sure you clear it out. Now I have 8, ठीक है, I have 8 at this point. What I will do is I will see and I will compare it from all the cards in the left hand. I will write it down also. Compare with all cards in left hand. ठीक है, तो first I am going to compare 9 and 8. ठीक है, now since 8 is less than 9, that means this card is going to be before 9, है ना, definitely sure. The second card is 6 and 8, है ना, these two are compared. Now we will see that 6 is less than 8, that means this card will be after 6. तो मतलब I have to place it in between. So what I will simply do is I am simply comparing it by each character one by one and finding the right position. ठीक है, and यहाँ पे left hand, right hand and I only have 11 left. अब now I come here. the card here is 11. I will compare it with each character one by one. So I have 9 and I have 11. One character from here and one card from here. So I will compare. Since 11 is greater, that means it needs to be placed here only, because it is greater than the very last element. So what I am doing here is I will place 6, I will place 8, I will place 9 and I will place 11. This is our left hand and this is our right hand, which is empty. ठीक है. Now the key observation, ठीक है, the key observation at this point is going to be this. ठीक है, listen to me at this point. In every iteration, I am picking the element. I am picking the element from my right hand and inserting it at its right position in the left hand. ठीक है. If I have to write this, at each position I am taking elements one by one from right hand and inserting it at its right position in the left hand, है ना. And since I am inserting elements at the right position, this is called nothing but insertion sort. We have not talked about time complexity, say space complexity yet. We will talk about it later, but first give a thumbs up if this sorting algorithm makes sense. Pretty simple, and I tried to explain it using the cards game also. For how many people does it make sense? है ना. So this is the concept that we will be taking on here. One more thing that you have to understand is, ठीक है, one more thing you have to understand it, at each iteration, पहले देखो यहाँ पे I had 4 elements in the right hand. Then I am, so in technical terms ना, हम इसको ऐसे भी कह सकते हैं that this is a unsorted region. ठीक है, and this is going to be the sorted region. Correct. Now there are some of you who wants the explanation probably once again. तो एक काम करते हैं, instead of doing it on the cards ना, let's do it on some elements only. ठीक है, then we'll try to visualize it and probably I think the code also will be pretty clear from that part. ठीक है, चलो, तो we will quickly do this. Let's say the elements that I have ना is 7, 4, 5, 2. ठीक है, and I have to sort these elements. अब क्या होगा, first step is going to be divide the array or these collections of elements into sorted and unsorted region. ठीक है, तो पहले हम वो डिवीजन कर देते हैं. 7, 4, 5, 2. Now I can say here that this region is the sorted region and this region is going to be the unsorted region. ठीक है, why am I calling initially one element as a part of the sorted region is, why? Because a single element is going to be sorted, है ना. If I would have been given just one element, so it would have been sorted. So initially I can assume that this is a part of the sorted region and this is the part of the unsorted region. ठीक है, अगर टेक्निकली देखो, इफ़ यू रिमूव ऑल दिस पार्ट, तो अगर एक सिंगल एलिमेंट 7 है तो वो सॉर्टेड है ना. दैट इज़ हाउ वी विल प्रोसीड. नाउ आई विल पिक एन एलिमेंट फ्रॉम द अनसॉर्टेड रीजन एंड प्लेस इट इन द सॉर्टेड रीजन. ठीक है, सो आई विल सिंपली डू unsorted region element is 4, sorted region element is 7. Now 4 is less than 7, that means 4 should come before 7. So I will say 4, 7, 5, 2. And this is now my sorted region. and this is going to be my unsorted region. One important observation is we are expanding the sorted region and we are decreasing the unsorted region, है ना? We are expanding the sorted region and the unsorted region is decreasing. And since we are picking an element from the unsorted region and inserting it at its right position in the sorted region, this is called nothing but insertion sort, है ना? बहुत ही simple सा concept है. Then we will take 5 here, right? 5 again, I will compare it with all the elements, 5 and 7. ठीक है, 5 is less than 7, तो मतलब 5 should be here. Now I say 4 and 5, तो 5 is greater, then it should be after 4. So it should be 4, 5, 7 and 2. This is the sorted region and this is going to be the unsorted region. ठीक है, again the last element is left. I will compare it with every other element. So I will compare first 2 and 7. So I start comparing from the end and compare. 2 and 7 less, 5 and 2 and 5 less, 2 and 4 less. So matlab 2 should come in front. If 2 has to come in front, then all these elements 4, 5, 7 needs to be shifted by one position. So I have 2, 4, 5, 7 and this is the whole sorted region. Clear to everyone? फटाफट बता दो if this is clear or not. बहुत ही simple concept है and after today's class no one should forget insertion sort. ठीक है, my objectives are also always this case that one should never forget the sorting algorithms once we have discussed this today, है ना? So what will happen is in today's class we cannot discuss more sorting algorithms, है ना, because आज we have a time constraint only of 2 hours, है ना, so we cannot do actually more. But if you are interesting, ठीक है, if you are able to learn this kind of a concept and if you are interested in learning, ठीक है, what you can do is you can go ahead and take the subscription of the code, right? You can also take the subscription. You can simply just go to this platform, unacademy.codechef.com, because I don't want that we all just leave it here and never be able to learn anything again. So you can just quickly take ahead and go and look at this course and try to see if this suits you or not. Okay, so you will see here I have a whole course on sorting and searching, and in this course we have 10 classes, है ना, 10 classes in which we have covered every sorting algorithm and every searching algorithm, right? So that is the concept that we'll be try to understand here. Every sorting algorithm here that can be beneficial to you and any sorting algorithm that you want to learn. Okay, so you can just simply go here, take the subscription, go to get subscription and take any subscription if you want. Okay, my referral code is by my name only. If you apply the referral code, you're going to get further discounts. Okay, this is just something I want to put forward because many of you are asking if this should be able to, and if you want to, you know, learn merge sort also, heap sort also. So I know you want all of you to learn. So if this is something that interests you, you can definitely go ahead and take the subscription, है ना. The fees is also mentioned on the website. You can check as per the price. Correct. So if this is clear, फटाफट implement करते हैं. I'm going to implement in Java only, right? Because I don't have the C++ IDE also present here, but the implementation is going to be exactly same because we are just implementing the loops kind of a scenario, right? Chalo, let's quickly see how the implementation will work. Chalo, let's quickly, I hope everyone is able to see the screen, right? Chalo. We'll discuss the complexity also. I have not yet discussed it, but don't worry, that will be discussed at the part as well. I want you to first see the implementation and the other things will just follow along. ठीक है, चलो let's say the elements are 12, 11, 3, 2, 5. ठीक है, ऐसे कुछ elements ले लेते हैं. Now I have to sort ARR. Let's say I am passing the length also. ठीक है. Now once the sorting is done, ठीक है, what we'll do is we will simply print the output. ठीक है. Let's say first we have the length, right? And here I am iterating. So the first element is already sorted, है ना? So the unsorted region will start from the first index. Right. So I am keeping the current element here. ठीक है. Now int j is equal to I minus 1. This is what? This is the start of the unsorted region. ठीक है. This is going to represent the start of the unsorted region. Correct. And after that I'll have j greater than equal to 0, right? And ARR of j if it is greater than key, right? And I am simply, so if this condition is true that the current element in the unsorted region is less than the current element, then what we were doing was we were simply shifting, है ना? हमें elements को shift करना था. ठीक है. And we simply go look at the next element. Correct. And also we are doing this. And in the end I simply place the element at the right position. And I think this is it. अब एक बार print करके देखते हैं output. Let's see if we got the right output or not. ठीक है. एक बार just to show you what kind of what is the step by step process here, तो उसका भी ना एक बार ड्राई रन कर लेते हैं, उससे सबको आउटपुट एकदम समझ आ जाएगा. लेट्स से इसको ऐसे प्रिंट करते हैं. ठीक है. एंड यहाँ पे लेट्स पुट अनदर, दिस इज जस्ट फॉर विजुअलाइजेशन. ठीक है. आई विल कॉपी दिस ओनली. चलो अब देखते हैं. देखो, नाउ इट शुड मेक सेंस. पहले क्या था? आई सॉर्टेड ऑल द एलिमेंट्स एंड 11 केम टू इट्स राइट पोजिशन, है ना? तो 11 and 12 आर सॉर्टेड. इन द नेक्स्ट आइट्रेशन 3, 11, 12 आर सॉर्टेड. Then 2, 3, 11, 12 are sorted and then the whole array is sorted. And in the end we simply printed the output. देखो, हर iteration में we are actually increasing the sorted region, है ना? And decreasing the unsorted region. And in the end we have the final output. Everyone able to see and visualize it? You don't need, I think, in case a dry run here, because we can see here at each step what is happening. 11 and 12 sorted, then 3, 11, 12 sorted. ठीक है. and then we have 2, 3, 11, 12, and then we have 2, 3, 5, 11, 12. है ना? This is the visualization that we will be doing at each particular steps. Okay, what is key here? Key is simply going to be the current element which needs to be placed at the right position in the sorted region. Correct? What do you think is going to be the time complexity here? Ab socho. Take a look at this implementation. See how I have done it. You can ignore this one. Okay? And tell me what is going to be the time complexity. Any ideas, anyone? Correct. It is going to be order of n square. है ना? Why order of n square? Because there is one full loop which is iterating over n minus 1 element, and similarly in the worst case this will also go to n minus 1 element. So the total time complexity is going to be order of n square. ठीक है? The space complexity is going to be, what do you think is the space complexity going to be? बताओ. Anurag, you can ignore that length also. मतलब I have just written it for visualization purpose, so the code is clear. I have just taken the length once only here and representing it by n. Order of n, अच्छा बताओ, कहीं पे भी in this code am I taking any extra array or any extra space? बताओ. Any extra array that I have took or any extra space I have took? That space complexity is order of 1, right? Space complexity तो order of 1 है. If I am not taking any extra space, then how exactly the space will increase? है ना? Do you think अगर यहाँ पे if I would have increased, let's say, to the size of array this, would it have affected the code? Do I need to take extra space? नहीं ना? Again the answer comes out to be really well. So if it is not relatable, okay, if it is not relatable, if a space is not relatable to the size of the input, we say that the space complexity is of order of 1. Hitika, but array तो आपको दिया ही हुआ है ना already. If you have to sort the array, then you would need the elements in some format, na? How is the size? How is the time complexity of the sorting part order of n? If for sorting I would have taken extra space, then I could have said कि भाई it is taking some extra space. But array is obviously given to you, na? Even if you are using any sorting algorithm, the array will be given to you. है ना? So that is the concept that we should all know. चलो. Let's now talk about some of the properties also that we should know about sorting algorithms. ठीक है? Some important properties. So we have discussed time complexity. We've also discussed space complexity, है ना? Let's discuss a few more things. The overall just give me a second. Just a second, alright, I think. Just give me a second. I'm trying to see why the pencil is not working. Just give me a minute, all right? Let me try to see it on both ends. My pencil is actually not working. Just give me a minute to see if this now works or not. Perfect. Chalo. Let's start again. I'll share my screen. So next we need to talk about a few properties also at this point, which are going to be very useful. Okay. So one another property that we should know about sorting algorithm is, first we talked about insertion sort, है ना? Can anyone tell me where exactly will be the applications of insertion sort? What exactly do you think is the application? Where exactly can you think of in a case where you have to apply insertion sort? मतलब sorting तो पता ही है, we needed to sort the elements. Any other use case apart from that? Correct. I think Vishnu gave the right answer at this point. Okay. So I can say that insertion sort comes in very handy. Okay. Comes in very handy when you have an almost sorted array. Okay. In those cases, I can say that insertion sort comes in very handy. Let's say एक example है in which let's say the elements are 4, 7, 3, 8, 9. ठीक है. Now if you will see here ना, if you will see here, out of all the elements, ठीक है, out of all the elements there is just going to be this element 3 which is not at its right position, है ना. Otherwise 4, 7, 8, 9 सब अपनी right position पे हैं. बस 3 अगर front में आ जाए यहाँ पे, that means the array is sorted. So we basically use insertion sort firstly when we have an almost sorted array. ठीक है. In that cases insertion sort comes in very handy because यहाँ पे हम वही तरीका use करते हैं to place the elements at its right position. ठीक है. Now what happens is in the second case, ठीक है, in the second example would be when used in online query. Now what exactly is that case, है ना? What exactly is that case? So let's say you don't have all the numbers present, ठीक है. That means elements are coming one by one. ठीक है. We are basically saying at this point that we don't have all the elements present with us. Elements are actually coming one by one. तो क्या होता है उस केसेस में what we usually do is we try to use insertion sort. Let's say अभी था आपके पास 4 and 7, ठीक है, तो आपने sort कर दिया. अब let's say someone gave you one more element A, तो आपने क्या किया, you simply took this element and placed it in between, है ना. Let's say not between, actually you put it after. ठीक है. Let's say अब किसी ने आपको 5 दे दिया, तो 5 you simply take it and put it in between. Let's say someone gave you 11, so you put it 11. So in case of an online query ना, आपको elements सारे नहीं पता होते, you don't know all the elements beforehand, you are getting elements one by one. ठीक है. So in those cases, so what you can do is whichever element will come, you will simply insert it. Next element will come, you will simply insert it. ठीक है. So these would be the applications of insertion sort. Clear to everyone? Correct. At random basis and one element coming one by one only. ठीक है. That is would be the concept of online queries at this point. ठीक है. We'll talk one more concept here. ठीक है. We'll talk about it here only, that the concept of stability. The concept of stability is very, very important and something that all of us should know as well in order to explain or use these wordings in a better manner. ठीक है. तो एक एग्जाम्पल लेते हैं. ठीक है. लेट्स टेक एन एग्जाम्पल हियर एंड देन ट्राई टू अंडरस्टैंड दिस कॉन्सेप्ट. ठीक है. एग्जाम्पल लेते हैं और फिर समझते हैं. लेट्स से आई हैव अ डेटा. ठीक है. और अ टेबल that is displayed on a website. ठीक है. एक डेटा अवेलेबल है वेबसाइट पे. तो मेरे पास नेम है और मेरे पास एज है. So the name of the people are Joe. Next person is Naman. Then we have Amit. Then we again have Naman. So there are two different people. Their ages are also given. ठीक है. अब आपने ना क्या किया, यू सिंपली सॉर्टेड दिस बाय एज. राइट. यू सिंपली सॉर्टेड दिस बाय एज. तो व्हेन यू सॉर्टेड ना, दिस इज व्हाट यू गॉट. $21 and that was Amit. Then I have Naman 24. Then I have 25 which is Joe. Naman that is 28. ठीक है. आपने क्या किया, sort by age कर दिया. Then what you did was you simply sorted by name. ठीक है. Now when I sorted by name na, अब there are two possibilities of output and you have to tell me which one is better. So the first possibility is that I get Amit. On sorted by name means in alphabetical orders, right? So I have Amit here who was 21. I was Joe who was 25. I was Naman who was 24 and Naman who is 28. The second possibility of output is this. Now tell me which one is better. बताओ. Take a minute, सोचो, try to think of it in this and tell me which one is better and give a reason also. I want all of you to answer also which one do you think is better and why. Okay, very good. I see all of you are already able to tell the answer. Very good. Okay, very good. Right, that is also correct. Anyone else who wants to tell as well? Bhavneet, first is stable or second is stable? देखो, try to see it once again. In which do you think is stability maintained? चलो, स्टेबिलिटी का कॉन्सेप्ट भूल जाते हैं, ठीक है. अभी तो हमने इंट्रोड्यूस ही नहीं किया स्टेबिलिटी, सो वी डोंट नो व्हाट एग्जैक्टली स्टेबिलिटी इज. लेट्स ट्राई टू सी, अगर रियल लाइफ सिनेरियोज में देखें, विच पर्टिकुलर आई वुड से ऑब्जर्वेशन इज गोइंग टू बी बेटर. ठीक है, लेट्स ट्राई टू सी दैट हियर. ऑल राइट, ठीक है. चलो, व्हाट आई कैन सी हियर इज ना, जब मैंने सॉर्ट किया बाय एज, तो व्हाट आई गॉट वाज, आई सॉ दैट हियर आई हैव नमन which was 24 years old, and then I had Naman which was 28 years old. ठीक है, but when I sorted by name ना, in this arrangement I saw that जो वो ordering थी ना, that ordering was still maintained between Naman and Naman. That means the Naman with less age is still present above with the Naman with the greater age. But यहाँ पे क्या हुआ, that was the other case. यहाँ पे exchange हो गया, right? The person who was the of greater age is now present at the top. ठीक है, so in these cases, ठीक है, in these cases we basically say that I have the stability that is, I would say, being practiced in this particular scenario. ठीक है, in array terms ना, if I have to now visualize it in terms of an array, I can say कि चलो ये एक array है 3 5 2 1 and 5 dash and 10. ठीक है, so these are two same elements only, but just to distinguish between them ना, तो मैंने यहाँ पे dash लगा दिया. I have put a dash. तो अगर stable sort होता, if it would have been a stable sort, it would have ideally looked like this, है ना. But if it would have been an unstable sort, it would have been like this. ठीक है, आई होप एवरी वन इज एबल टू सी इट हियर, है ना, हाउ डिफरेंट स्टेबल एंड अनस्टेबल सॉर्टेड, उसका रियल लाइफ एग्जाम्पल इज प्रेजेंट हियर. ठीक है, व्हेन वी वांट टू मेंटेन द ऑर्डरिंग इन अ केज, इन अ एज काइंड ऑफ अ सिनेरियो, आई प्रेफर दिस पर्टिकुलर पार्ट. ठीक है, आई कैन से इन विच द ऑर्डरिंग इन अ स्टेबल सॉर्ट, ordering of the elements is maintained. ठीक है, now what do you think, is insertion sort stable? Now this is like a homework problem for everyone. I want all of you to think about it. Is insertion sort a stable sorting algorithm or a unstable sorting algorithm? No, I'm not going to answer that. Everyone is going to think for their ones and also give a reason also. Why do you think there is stable or unstable? ठीक है, just take a mental picture of this part of how exactly I showed how the stability matters and does not matter. Then we will move. ठीक है, चलो, आई थिंक विल एंड सॉर्टिंग वाला पार्ट हियर ओनली. ठीक है, बिकॉज इट्स ऑलरेडी 1 hour एंड वी डोंट हैव much time to go into deep with this. We'll just quickly take a binary search also. ठीक है, we'll quickly take binary search also and उसके भी कुछ question solve करके देख लेते हैं. Clear with everyone? एक बार फटाफट thumbs up दे दो for all those who are attentive in the class right now, so that we can move on to the next topic now. Because in just 2 hours constraint, it is very difficult to actually cover both topics in great detail, है ना. फटाफट दे दो thumbs up एक बार सब. चलो, perfect. Let's quickly move. All right, chalo. Now we'll move on to the second part. that is actually going to be binary search. Okay, and before that, before actually covering binary search, okay, before actually covering binary search, first let's talk about what searching is. Okay, we'll just first talk about what searching is, and then we will move on to a different type of a searching algorithm. Okay, let's say question आपका ये है that you are simply given an array of let's say integers. ठीक है, you are simply given array of integers and you have to check if an element x is present in the array or not. ठीक है, this is what you have to check, right? And we basically have to check if an element is present in the array or not, correct? So what do you think are you going to do? मतलब only this much information is given to you, ठीक है, only this much information is given and nothing else is given to you. Now what do you think your approach will be? करेक्ट, आप सिंपली ट्रेवर्स कर लो, सिंपली ट्रेवर्स कर लो एरे पे एंड यू फाइंड द एलिमेंट. सो इफ आई हैव टू राइट द सूडो कोड, सो इट विल बी boolean value is present, so I have to look for the element x in this array, है ना. So I will simply iterate starting from I till the length of the array and I will check if the current element a of I is equal to x, then I will simply return true, है ना. This is the approach that I will take into consideration, right? Now what basically happens is, ठीक है, what basically happens now is the case that let's say you are also given that the array is sorted. ठीक है, now at this point आपको एक ये additional condition बता दी है that the array given to you is actually sorted as well. तो क्या होता है when you are looking for an array ना, or let's say when you are looking for an element, right? तो the realization should be first, let's say if you are looking for something, so you should know the search space, correct? I hope everyone agrees to that if I am finding something, let's say I have to look for a particular boy, ठीक है, in a class. So first I know that the constraint is that that boy will be present in this class. So that is the search space, है ना. Search space is that entire area where I need to look for. Secondly, I also need to know what student I am looking for, है ना. मुझे ये भी condition पता होनी चाहिए कि which student I am looking for and in which search space. ठीक है, तो let's try to do it in that way only, correct? Now let's see at it in this way. Let's say the elements are, since the array given to us is already sorted, let's say it is going to be 2, 3, 10, 22 and 44 and let's say 56, right? Now what exactly is going to happen now? Let's say you are looking for element 3, right? Now what exactly happens is, first I will define the search space. ठीक है, first we will define the search space at this point. So in order to define the search space, what exactly I am doing is I am taking two variables or two pointers. There is going to be a left pointer and there is going to be a right pointer. ठीक है, Now what exactly happens is that when I use this, right, when I use this, so I have defined the search space that my value, the element that I am going to look for is going to be present in this area, right. Secondly, I now first check the elements. Okay. Now when I have to check the elements, I will be doing it in a more optimized manner, right. How will I do it in a more optimized manner is, first I will check the minimum element. Okay. Now when I check the minimum element, so if it is, let's say, index 1, 0, 1, 2, 3, 4, 5. So the minimum element is going to be 0 plus 5 by 2, which is going to be 5 by 2, that is going to be 2. So the middle element here is going to be this. Now what you will do is, you will check the middle element with your element, right. So this is the middle element and your element is, let's say, x. Now you will compare both of them. Now when you will compare, you will basically see that your element x is less than the middle element. Why? Because the middle element here is going to be 10 and you were 3. So the property here is, if this element is 3 that you are looking for and the current element is 10, then I can basically say for surety that the answer, if it exists, will be in this region. Can anyone give me a reason for that? That why do I think that the answer is not going to exist here, but the answer is going to exist here? Right, because it is a sorted array, है ना. Try to see it in a visualizing terms कि अगर मेरा current element 10 है ना. If the current element that I am looking at is 10 and if I say the array is sorted, that means all the elements after it are even going to be greater, है ना. All the elements after this element are going to be even greater. So it does not make sense to look for the elements on this side. It only makes sense, okay, it only makes sense to only look for the elements on the left side. So that is why I can basically say that if this is the condition, okay, if this is the condition that we have so far, in those cases I will simply look on the left side. Now when I look for the elements on the left side, you will see that my array has now been reduced to these 3 values. Now when I say my array has been reduced to these 3 values, this is how I define the range. So this right variable actually comes here. Now I again try to find the mid. The mid comes out to be this. And this is only equal to the element that I have been looking, and hence I have found the answer. Correct? Makes sense to each and everyone that how you are shifting the search space. Okay? You are shifting the search space in each iteration and taking a decision. And in each and every iteration, you are always decreasing the search space by half. Yes, Yash, we will be ignoring that. Did I miss that part? Yes. So actually, if you want to have even greater constraints, you can just reduce your search space to 2 and 3 also, right? It's just the implementation of less than, right? It is not going to affect the overall complexity. Dhanush, I took that on the basis of the mid formula. That is L plus R by 2. Let's quickly see the implementation also for binary search, and then we'll quickly see how we can implement this. Okay? Let's say I do this. So we'll take an example after this as well to basically visualize it. Now let's say I am looking for the current element and the array looks like this. So the array given to us is already sorted. Now I have to basically look for a particular element. Let's say the element that I am looking for is 47. Now I simply call binary search for this particular array. And I simply pass the array and the element that I need to look for. Right, and we will simply here see if the element that we were looking for is resulted found or not. Let's say I return an integer value, and again the first step is to first define the search space. So here my search space is going to be the first element, starting from the first element and ending to the last element, right? First step is to define the search space. And till when will I keep doing this process? Till the time the search space is reduced to one element. Keep finding the element till the search space is reduced to one element. So to define that property, we'll simply do left this is the property that with which we will define the question. Now first we will take the middle value. So this is how I will take the middle, and this works on an integer based indexing. Now the first property that we are going to simply check is if the element is equal or not, right? So if the current element that I look at is equal to the element that I am looking for, then I will simply return the index. So here I am printing the index at which the particular value is found, right? This is what I will be returning. Sorry. Now tell me what should I do. If the current element is less than x, in which direction should I go, left or right? Arey, people are confused about this also. If the middle element is less than the element that I am looking for, if x is greater than the middle element, then I should move to the right half. And in order to move to the right half, what I will simply do is I will do left is equal to mid plus 1. Right? This is what I will be doing. In the other case, what will happen is, in the other case, I will simply move to the left half. In order to move to the left half, I will simply do right is equal to mid minus 1. You know? This is what we will simply do. And if the element is not found anywhere, I will simply return minus 1. Right? This is what we will be doing. Now let's quickly run this once and see if this works or not on all the cases. See, so we were looking for the element 47. It is present at 1, 0, 1, 2, 3, 4 and 5th index. Correct? This is how we are going to find the element. Now let's say we are looking for the element which is not present. Let's say I am looking for 41. So it will say minus 1 because the element is not going to be present. Clear to everyone? Just quickly tell me if it is clear, because after this we will solve problems. Clear na sabko? I hope everyone is clear with this. I'll show the code once again, don't worry. And if you wonder about the time complexity, okay, if you wonder about the time complexity of what exactly and how much time is it actually going to take to implement this, so what exactly we have to do here is, you can think of time complexity in this way. The time complexity, if I have to show the recurrence relation, it is going to be something like this. And how exactly did we get this is, right, and how exactly did we get this part is, you will see here that if this is the array that has been given to us, if this is the left part and if this is the right part, and if this is the mid part, at each step we divide it into two phases. So the first part is going to be left and mid minus 1. The second part is going to be mid plus 1 and right? And based on that we take a decision. Either we have to move to this part or we have to move to this part, right? And after this, what I can simply do is, let's say I simply pick this part. So again, I will have to take a decision. Let's say this is now the mid one, and here now the region is again getting smaller and smaller, right? It is getting smaller and smaller. So we can say, and each iteration we simply divide it. We simply divide the region into half, and plus we do some constant operations. And the constant operations are nothing but these operations, this finding mid, this doing comparison and everything like that, correct? Okay, now let's quickly not waste any time and solve some questions so that we get a better understanding of the type that we want to cover today, right? Okay, so what we will do is, let's say the question given to you is, you are basically given a, I would say, a value. You basically have to find the square root. Implement square root in your own language. Right? Now what exactly happens at this particular point is, let's say I will be giving you some value. Let's say 25, and you have to give me its square root, that is going to be 5. Now let's say I give you another value, let's say 10, and you have to find its square root, which is going to be some decimal value, but you can return the nearest integer. Let's say I give you 16, so you have to give me 4. Very simple question in just where you have to find the square root. So given a value x, find square root of x. Let me show you. Given a question is very simple. Given a value of x, find its square root. And you cannot use the inbuilt square root function, alright? You have to implement your own square root function. For those of you who are thinking they'll use the inbuilt function, right? Just try to use a function yourself, or make a function yourself. I hope everyone has seen the question. I'll just quickly disconnect for a minute. Try to think how you will solve this. And put your approaches in the chat. Yes, I think you can use the power function, although I will suggest not to use that also. All right, I see a lot of people answering. Anyone else wants to share their approach? The question is actually very simple. Let me just quickly check something, then we will discuss the solution for this problem. Chalo, let's discuss. The solution was actually very simple, not much that you had to do. ठीक है, I'll just explain the pseudocode. Implementation all of you will be able to write on your own. ठीक है. All right. So what you had to do all was, ठीक है, what all you basically had to do at this particular point is that let's say you are given a value, ठीक है, you are given a value x, ठीक है, and you need to find its square root, right? Now the very basic definition is, like I said, I am looking for something, है ना, I am looking for an answer that is the square root of x. The second thing is, like I always say, whenever you are searching for something, you need the search space, right? And if I define very loose bounds, I can basically say that the answer will exist somewhere in this range. How many of you agree to that? That the answer will exist between this range. तो हमने क्या किया? What we have done is we have found the search space that the answer is going to be existing in this range. Now I think the concept again is very simple. You can just simply say find mid. You can just say that you can find the middle point at this point. So let's say the mid is going to be somewhat 0 plus x by 2. It is going to be x by 2, correct? This is what the mid is going to be, right? And I can just simply check at this point that once I find the middle value, I can simply say if mid into mid is going to be x, that means I have found my answer, right? I can simply return the middle value because that is going to be my answer, correct? What else I can do is, if mid, now I want you all to tell me, if mid cross mid, that is mid into mid, is greater than x, now what do you think? Where the answer will exist? Very good, very good. That is what I wanted all of you to understand also, that at this point I am simply going to left. So I will go to left because my current value is greater and my answer will exist on the left side. And if I simply say that mid cross mid is less than x, that means my answer is going to go on the right side. Simple as that, nothing more that you had to do. Okay, let's say the value that I currently took is 25, right? Then though my range is going to be 0, 25, I find the middle value. The middle value is going to be 12. When I do 12 cross 12, it comes out to be greater than 25. Correct? It comes out to be greater than 25. Then I simply say that I go to left. When I go to left, that means my search space is reduced to 0, 11, right? And when again I try to find the mid, the mid comes out to be 5, because 0 plus 11 by 2 is going to be 5 only, because we are taking the integers value. And then what I can simply do is I can check here if mid cross mid is equal to x, which is true, and this is my answer. For how many people is the question clear? Did you guys see we actually did not use any power function also, mathematical library also, and the answer came very, very easily, right? We did not do much. The code was very, very simple. We applied a very simple concept, right? And that is how I got the answer. This is actually called applying the concept that we studied now. This is called applying binary search on answer. ठीक है. This is called applying binary search on answer. Why do we call that this is? Because we simply have to apply binary search on the answer range. There is no array that is given to us right now. There is no function that was given to us. First we tried to find out where the answer could exist, what is the range of the answer, right? And then we are trying to solve it. This is the simple concept that we had to do. Vasant, we are trying to find square root using the middle function. The main property of I would say finding the square root was that the square root value is always, let's say for 16, let's say the square root value is 4. The property was 4 into 4 is equal to 16. One other method that you would have done was, let's say the current value that is given to you is let's say 25. One way could be, first you could have gone to 0, then you would have done 0 comma 0, then you would have done 1 comma 1, 2 comma 2, then 3 into 3, 4 into 4, and you would have gone on till this point to find the answer. But a better way to find the square root value is to use binary search. Simple as that, the concept that we are using. Okay, let's do one more question. Okay, let's do one more very interesting question. Then we will try to understand the implementation for that as well, right? Let me quickly get that question for all of you. All right. Take a look at this question, read it and try to understand. I hope everyone can see the question on the screen. Try to read the question, then I will show you the cases as well. I'll give you the link also to all of you so that you can read it yourself also. Okay, I'll share the link. In the previous question, okay, in the square root wala question, we have taken integer values. You can take the float numbers as well, right? We are not defining the number on integer values. You'll have to take float and then try to solve the question. Everyone is able to see the question, right? I've given it in the chat as well. If you want, you can like take a look across the question as well. If the question is clear to everyone, try to think of an approach to solve this. Or do you want me to explain the question? Should I explain kya? Okay, people are asking for 1 minute. Let's just give like 30 seconds more, then I'll just like explain the question. Okay, I'll explain it, don't worry. Okay, so the question basically says at this point that you need to color a floor plan, all right, and then the size of the floor plan is also given to you, that is going to be 3 cross n. So there are always going to be 3 rows only. This is going to be the first row, the second row, and the third row, and there can be as many columns as you want. There is no constraints on the column, and you have tiles of size 1 cross 1, all right, and the tiles are of red, green, and blue tiles. So I have red tiles, green tiles, and I also have blue tiles, all right. I think this much part is clear. Then you have to tell what is the maximum number of columns you can color such that every column has at least 1 red and 1 blue. So the constraint is that each column should have at least 1 red and 1 blue. So each column should have at least 1 red and 1 blue. So these two I would say rows for a particular column is fixed, because they are obviously and always going to be filled with 1 red and 1 blue, and you have to tell the maximum number of columns you can fill. Let's take an example now. All right, so let me read what the test cases are. So in each case, test case contains a single line containing of 4 upper space integers. So it is n, that means I think the number of columns, then RGB. Okay, let me write it down, n RGB. So that is 4 3 3 4 4 4 1 4 and 2 4 1 4. Okay, now all of us will see how together we can solve this and how does the test cases work. Alright, so now first I have, in the first example, I have been given a 3 cross 4 matrix. So this is going how it is going to be look like. Now in this case, you will see here that I have 3 red, 3 green and 3 blue tiles, and I obviously want and compulsorily want 1 red and 1 blue. In this case, what we will simply going to do at this point is that 3, 3 and 4. So definitely red will be here, blue will be here, right? These two are compulsory. The third one could be anything. So let's say I put a green here. So after filling the first row, I am basically left with 2, 2 and 3. So that is red, green and blue. Then I have these many left. So I will again, for the next column, I will have a red here, I will have a blue because these both are compulsory, and then I will have a green. So this is what I will have, and I am left with 1, 1 and 2. Then again I will have a red here and a blue because that is compulsory, and then I can fill any color that I want. So I will fill a blue color, and this is what I am left. Do you think I can fill one more column here? Do you think I can fill one more column or not? No, right? I cannot fill one more column. So for this test case, the answer is going to be 3. Alright. For the next case, what we will see is I again have 4 columns. I think there is one more constraint in the... Okay, alright. No, nothing. Let's discuss the another case in which I have 4 rows, 4 columns basically. I already think many people are getting the hint of what we are trying to do. So I have red, green and blue, 4, 1, 4. So I can fill this way. So I have red, I have blue, and let's say I put a green. So I have 3, 0, 3. Then again I can have red, blue and no green left. So I can again put a red only. So that will be 1 left and that will be 2 left, right? Then I can put a red here and then blue, blue. So this will be 0, this will be 0. So for this case also, the answer is 3. Now in this case, what you will see is, I only have 2 columns. So this is how it is going to look like. Now in this case, you will see at this point, in this case, what you will see is I have R, G and B, correct? Yes. So I have 4, 1, 4. So first I can put R, then I can put B because both are compulsory, and then a G. So I am left with 3, 0, 3. Again I can put an R, B and then again B. So I am left with R of 2 and this of 1. But there are no more columns to be filled, right? So there are answer going to be 2 only because I have filled more both the columns. I want to fill more, but there is no option, right? Because I have filled all the tiles. So the answer is 2. Now is the question clear to everyone? Just give a thumbs up first if the question makes entirely sense. Perfect, very good. Now think of a solution, although I think most of you will be able to get it now, but still try to see if there's anyone else who feels they don't get the idea. Ankit says how to code it, that's the problem. Don't worry, we will discuss that. I'll just give like one more last minute, then we will discuss the solution, alright? First, try to think of an approach. Is everyone able to get the approach of how you are going to solve it and what will be the overall idea? Okay, let's discuss. I want everyone to focus here now, right? The first thing and the first claim that I will make, and I want everyone to think of it in that terms also. Tell me if I am correct or not. I think the answer is bounded on the fact how many red and blue tiles you have. How many of you agree to it? The answer is bounded on the fact on the total number of red and blue tiles you have, right? Because if I say red, green and blue, if I say that let's say I have only 3 red tiles, I have let's say 100 green tiles and I have 2000 blue tiles. Even if this is the number of tiles that I have, the maximum tiles that I can fill is 3, or maximum number of columns that I can fill is 3. Agreed everyone? Because each red and blue is dependent, right? These two are definitely going to be filled by a red and blue. We do not care what we fill here, but definitely a red and blue is required. Dependent on n also, Lokesh, but let's just consider the n constraint is not here. For the time being, let's just consider the tiles constraint, right? So I can basically say the answer is dependent. Now don't you think I have defined a range that the minimum number of tiles, minimum number of columns that I can fill is 0. The maximum that I can fill is going to be the minimum of red, blue and the total number of columns. Right. Let's try to code this now together, and we will try to visualize it as well, and you will be able to get the idea also. At each point I'm going to ask you if you are clear or not, so just make sure you give a thumbs up if something makes sense. Let's take the input in this sense only. So first we'll get the total number of test cases, then the total number of columns, then red, blue and green. Alright. So the total number of test cases, then we first take the input for the number of tiles, number of columns. Alright, and in the end I will simply print the total number of columns that I can fit, and I will pass it to the function color. I will have red, blue, green and alright, perfect. Think we have all the values. Okay, first step, like I always say, is going to be defining the search space. So we have already discussed the search space. So the left search part of the range is going to be 0 and the right part is going to be math dot minimum of n and the minimum of red and blue. Just give me a thumbs up if everyone is still with me this point. If everyone is clear what we have discussed so far, then only I will move forward, otherwise it will not make sense to all of you. Clear now? So we have just defined the range here. Total number of columns that can be filled. The answer will lie within this range, right? The answer will definitely lie within this range only. Now what basically happens is, let's say this is my answer and in the end I will simply return it. Now what will happen is, I will simply apply binary search like I always do, and now you are going to help me to tell what will be done at this step. I am basically saying that, let's say the mid is going to be left plus right by true, right? This is how we find, and this we are finding the mid. And what does mid represents? Mid represents the number of columns that can be filled. Now let's say there is some procedure. Let's say there is some functions to which I pass the middle value and all these values. Okay? And this functions tell, this good function is basically going to tell me if I can fill mid columns or not. Now tell me, what should I do, in which direction should I go if I am able to fill mid number of columns. So I have randomly taken a value between the range, and now we have to decide if I am able to fill those many columns, in which direction should I move. I want to maximize the total number of columns that I am filling. This function is basically going to tell me if I can fill that many columns or not. Definitely I should move right. So I will simply do left is equal to mid plus 1. And also this column, this number of columns is definitely an answer. So I will store it in the answer also. And if I will find a better answer, I will store it in that also. And in the else case, I will simply move to the left. The only part, this good function checks if I can fill mid columns or not. Now I basically have to check in this function. Now I am going to write something and you tell me if that claim is right or not. Then only we'll write the statement. If I am trying to fill mid columns, I want to check if I can fill mid columns or not, then I need at least mid number of red and blue tiles. How many of you agree with this statement? If I have to fill mid number of columns, then I need at least mid number of red and blue tiles. Correct? That is the statement that I have to agree on. So that basically means if I have 2 rows of mid number of columns, for the third row of all mid columns, I basically need mid number of tiles of any color, है ना? How many of you agree to this statement also, that once I have filled 2 rows, okay, once I have filled 2 rows at this particular point of time, let's say I have this will be always filled by red and blue, and this can be filled by any color. This can be filled by any color. I just need mid tiles of any color to fill this particular third row, right? And obviously this condition, this mid number of tiles of red and blue, this is always going to be true. Why? Because the right range is always the minimum of red and blue. Then I can simply just check that once I have used mid tiles of red, how many tiles are left? Red minus mid, Once I have used mid tiles of blue color, how many tiles are left? Blue minus mid, and the rest of the tiles were green. If this value is greater than mid, I can simply say that you can fill these many columns, otherwise not. And if you want to check also, if this runs on all the cases, see, I get 3, 3 and 2 as the output, and the output was also 3, 3, 2, right? Just simple condition that I am checking at this point, that the rest of the left colors after filling 2 rows of mid columns is greater than mid. Make sense to each and everyone, right? The good functions basically checks if we can fill these many columns or not. Correct? That's the basic idea that the function is basically going to check. And this is what we had to do, and this is how you are going to solve questions from, I would say, binary search. This is like the difficulty level which is actually expected in Div 3 as well. Gagandeep, please use left is less than equal to right. Alright? That is the concept. The concept again is very simple. We are just trying to fill rows. And we have to check if we can fill a certain number of columns or not. If I can fill certain number of columns, then we can simply say that the answer is going to exist on the right side because there are greater number of columns, and otherwise the answer is going to exist on the right side. Shazan, you will need the good function in every language. The good function is not dependent on Java. I know might look like a little bit tough, but try to understand the concept. Okay? If you want, you can basically take a look at the class once again also and try to understand this, and then try to implement the question again on your code. But the concept was very simple. To first define the range, if you will look at the code here, I actually just did the binary search part and nothing more than that at this point. That I was just trying to see here the range. So first I defined the range, the left and the right, then I saw the answer, then I simply applied binary search on the answer. Shaumya, you can say it was a medium level question. Not too easy, but something that you should try once again also on your end to try to simplify the concepts, right? So I hope the concept makes sense. You were able to learn a little bit higher difficulty level question also. I know it was not a pretty trivial question, pretty trivial I would say approach, but yes, this is how you should look at binary search also. In all the cases, it will not be present that you are simply given the array and you simply have to binary search a value in that. That is not the case in most of the cases. You will have to look for some values. Thank you, Saloni. Thank you so much. Gorak, it will not be shared right now. It will be shared at the end of the class. Probably by I will say by end of day. All the thank you everyone. Thank you. Chalo, so I think this was the classes that I was supposed to cover as a part of this course, and I hope everyone had fun learning, right? Thank you everyone, and please do attend the Ask Me Anything session also that Sanket and I are going to take just after this class, and then we are going to take up any doubts that you have in that part, right? So if you have any doubts, you can definitely join that class and clarify the concepts if you're still in 3rd year and 4th year and you want to clarify those concepts. Thank you. Bye bye.